Let's get to work. Now, traditionally, keynote speeches are about trends in the industry, and I have nothing to say about that. I don't know. But what I talk about is technical things to try to add value to you as a professional to help you understand these nitty-gritty security issues in a more in-depth way. And my personal mission is to make sure that all of us can communicate these issues well to software developers, because we're not going to solve security problems by testing. We're not going to solve security problems by threat modeling. We're going to solve problems by enabling developers, is my opinion. We want to teach developers to threat model and teach developers to understand how to write secure code. Now, cross-site request forgery is no longer a part of the OWASP top 10. And it's kind of mislabeled in ASVS as an access control problem. And with the advent of new standards to address request forgery, it's something I see we're talking about less. So I want to talk about it because I still think it's a really important problem. And I watched a couple of my customers get hit by cross-site request forgery in a way that was really damaging. So in my world, it's still important that we get this right. I think it's really fun to talk about. Let's do it. My name is Jim Manico. I'm an application security instructor and the founder of Manico.com. We teach developers to write secure code as our main mission. I've been a former board member at OWASP. I co-manage the ASVS and the cheat sheet series. ASVS is with Ilar Lang, myself, Daniel Cuthbert, and Josh Grossman. And I manage the cheat sheet series with Jacob Markowski, and it is a joy to work on these projects. It really is. I learn a lot myself, and I work with outstanding people who are passionate about application security, and that's my joy. I've been developing software for about 25 years now, and I authored an older book on web security. Who cares? Let's get to work. Don't hack without legal permission. Yeah, that's right. So what is request forgery? There's two request forgeries we're going to talk about. Cross-site request forgery and server-side request forgery are the two forgery types we care about today. Let's look at cross-site request forgery first. Imagine I'm logged into the bank, and I visit some attacker website. They can drop HTML and JavaScript into my browser that forces me to make a request to the bank, including my session cookie if I'm logged in. Now, traditionally on the web, older browsers, they don't care what page you're on when you initiate the request. They'll just let the request go and include the cookie automatically if there is one for that domain. So basically, I can host a request on an evil website. So when someone who's logged into the bank visits my evil website, I give them a web page that forces them to make an authenticated request to the bank to transfer money or similar. This is a big problem. This literally undermines the security of the web as we know it. And here's a couple examples of what this is all about. So I'm going to get my pen out here. There we go. We're looking at evil.com, right? And here we have an image tag which is not governed by any policy. By default, I can load an image anywhere on the web. It's the old school artifact that still behaves that way. So I'm going to make a request to mail.google.com, delete all the messages, and auto confirm it. The height and width are 1 pixel, so you don't even see the broken image icon. It's 1 pixel, not visible to a user. Look at this. Look how interesting this is. It's not visible to the user. They visit an evil website, and it forces the user to make a transaction without any action on the user's part. This is a big deal. Think about all the sites and administrative activity you provide, and imagine an attacker forcing an admin to do whatever the attacker wants. This is pretty destructive. And so here I have some server here where I'm transferring money for a bank account. Again, I'm hiding my track so you can't see it. I'm hiding the artifact that's doing the request forgery so the victim can't see it. And down here, I got this webmail program. I'm sending an automatic email automatically saying nasty stuff to my boss. And I'm using REL is no refer. This is a standard attribute for a link that says, don't send the refer header. Hey, by the way, what would the refer header be of this request? Oh yeah, it'd be evil.com, letting you know where the attack was hosted. So I'm gonna hide my tracks here. And so This is why request forgery is not in the data, by the way. Data has limits, by the way. Request forgery is not a part of our data set because it's so easy for me to hide my tracks as an attacker. If you're hit by request forgery, it is non-trivial to do forensics to see just how big of a problem this is. So I suspect it's more of a problem than the data shows us. But luckily, technology is picking up in web security standards where we need less developer awareness of this, but we still need some, but we're getting better by default, which we'll look at in just a bit. And so what's the result of all of this? The result is that the image loads, the request is made, cookie goes with it. The attacker doesn't see the response, but they get the money, right? They get the money, they get a result of the attack occurring in some way. Here's a real famous attack. There's not a famous attack. That's just a point I'm trying to make. The other point with cross-site request forgery is I can use it to attack intranet sites. And I've seen this happen among fired workers and disgruntled workers before in the tech world. So here I have an iframe on my evil website where the style makes it non-visible, right? There's a width border 0, and it's not going to be something that we see, even though it's active on the DOM. So then I have this form, which is submitting to an internal website. Now, on the internet, I can't hit your intranet. But if I can get you to visit my website that's evil, and this is downloaded in your browser where you're logged into your intranet by single sign-on, then I can hit this vendor money transfer form and have money sent to me as the attacker by forcing an internal employee to hit an intranet app through cross-site request forgery. Now, this is what scares me the most, because it's not just about attacking other websites on the internet. It lets me go after intranet sites, which are traditionally way less secure than our internet sites as a whole. So there you go. Cross-site request forgery attacking intranet sites. This is one of the most famous incidents or famous known attack types against a certain service. This is back a long time ago in 2006, where for the DVD ordering service, this request forgery adds a movie to the queue, waits 2 seconds, calls load image 2, which then adds this DVD movie to the top of your queue. And when this was released by an attacker, it was an inappropriate movie for kids. But this is a way to show that even a site like Netflix, back many years ago, to their credit, would allow me to put this attack up and force users to have movies shipped to their house physically that they never ordered. Interesting. Last, what do we got here? This is a great incident back in 2012. This is an incident against the entire nation of Brazil. Brazil has 3 major telecoms. 5 million people were hit by this vulnerability in the Comtrend ADSL router that was given to people across Brazil as just for signing up for internet access. And this attack would hit the intranet of your router and go after the admin console. So 192.168.1.1, that's nothing on the internet, but on your personal intranet, that's your router. So this attack, when you're behind your router at home and you visit this attack, it will force you to hit your vulnerable router, change your password to a known password, and the attacker then modified, let's clean this out. The attacker then modified your DNS to become an attacker DNS. Hey, what if I can set your DNS server to, what if I control your DNS as an attacker for 5 million people across Brazil? What can I do? Botnet, go phishing. This is basically a bank robber who used this mass attack against Brazil to phish through DNS to get banking credentials. Brilliant. It's another CSRF cross-site request forgery attack against an intranet. Fascinating to me. So again, I can punch through your internal network. Your single sign-on makes it easier. A lot of people implement single sign-on where I'm an employee, I show up, I log in, single sign-on, you give me a cookie, and that's an ever cookie all day long. I go to lunch, come back, it's still active. This is nonsense. This violates session management. For single sign-on, I like to break up my apps into different risk tiers. If it's a low-risk app, single sign-on, you're in. If it's any kind of high risk, I do another multi-factor challenge, so you're not giving staff seamless access to all your admin apps. It's nuts. That's how most folks roll, and it's dangerous. Here's an example of how to weaponize it as well. Now, how do you stop this problem? CSRF defense. There are 2 main defenses and 3 extra defenses I want you to consider. Number 1, your app should have, if you're using cookies for session management, the cookies may have a session ID, the cookies may have a JSON web token. But the reason CSRF, cross-site request forgery, exists is because of the automatic nature of cookies. So if you're not using cookies, if you're like putting a jot into session storage and you're not using cookies, this is not a problem. So step 1, don't use cookies and CSRF goes away. Hey, but if you're storing your token inside of local or session storage, one cross-site scripting, and I've stolen your cookie. If you put the token in an HTTP-only cookie, I can't steal the cookie. I can still abuse it and do request forgery. So at some level, it doesn't matter, but I digress. So if you're using cookies, you want to use synchronizer token pattern for a stateful traditional session-based web app. And if you're using a stateless API that uses cookies as a session transport, you want to use the famous double submit cookie pattern from John Weilander when he was working for a Swedish bank back in the day. He invented this back in the day, double submit cookies. We still see that in Angular and similar to this day. A few other defenses: re-authentication in critical boundaries, great idea. Same site cookies, they're a standard around by default. That's really powerful with same site cookies. You can even do header verification to check the origin of an incoming request. So I tend to recommend synchronizer and same site and re-authentication. I don't do header verification much anymore, but I see some people still doing it. We'll talk about it. We also got double submit cookies for our stateless apps. So let's go traditional web apps, right? Which still exist in the world today. You jot freaks, JSON web token. We still got regular sessions for some of us out there. So when you log in, generate a large CSRF token. And when you're rendering a form, extract that token from the session and put it in a form as a hidden variable. For any sensitive transaction, when that's submitted, compare the token in the form to what's in your session. And if you get a match, you've passed the CSRF test. And if it doesn't match, reject. Now, this is built into your framework for all modern web frameworks. So it's something that you really want to consider using what your framework offers you as your first approach to this. And if it doesn't give you this is what you want to build. Pretty straightforward to do so. The other thing is your GET requests should not run a transaction. This is not just me saying this. This is the original HTTP standard. We're talking RFC 216, RFC, Alexa, quiet, RFC 2616 9.1.1. The get and head methods should not have a significance of taking an action other than retrieval. Null and potent means no power. Idempotent means all requests have the same effect. So your get request should look up a resource or render a read-only web page, and that's it. It shouldn't run transactions that can harm you. Therefore, you should not need to protect your GET requests from CSRF. A GET request should never log a user in, delete, run a transaction. It's just look up data. So that's basics. We know that. That's basic session. Now, when it comes to stateless services that use cookies, there's no server-side state to save the token in. So what do? We do double submit as a pattern. And I still think you should build these in if they're not in your framework. So the way double submit works is it's not depending on server state at all. What it does is in JavaScript, when you hit submit, it's going to automatically create a cross-site request forgery cookie with the value in it, a significant size value. And then this JavaScript will set the same value in a request as a request parameter or a custom header. And all that the server does for sensitive transactions, it looks at the cookie, make sure it's non-null, non-zero, looks at the request value, and make sure they match. If they match, we've passed the CSRF test. If they don't match, we're going to reject it. This is necessary for cookie-based APIs only, right? Also, the reason this works is because an evil domain cannot read the cookie to include it as a parameter on the fly. And all the servers have to do, whether it's a serverless function, web microservices, or what, it's got to reject the request if the cookie and parameter do not match. Necessary for cookie-based services. So what else? We also have this challenge response. Like if I'm going to transfer money, force the user to authenticate. This alone does a really good job at stopping request forgery, but it's another defense we can add in, just re-authentication for sensitive transactions. Now, what makes this exciting, though, is how browser standards have risen in the last few days. The advent of the same site cookie is amazing in its capacity to stop request forgery. We have all these new cookie standards over the years, and the same site ones is a recent one. And what same site does is, and there's two modes, there's strict and there's lax. Let's start with strict first. Strict says cookies will not leave the browser unless the user made a request in the page where the page, the domain of the page, and the domain of the server are the same registrable domain. Because what's request forgery? Go back a second to the beginning of this talk. Request forgery hosts the attack on evil.com and submits it elsewhere. So the page and the server target are different domains. And what same site cookies do, they say, hey, if your browser and server are not the same domain and the request was not initiated in the page itself, we're not going to send the cookie. This is one of the greatest standards to help us eliminate request forgery. What lax says, lax is to support affiliate links and similar. Lax, if you say lax, what you're saying, even if the request was originated from like text, you text me a link and I press on it in email, I press on it in messaging or through social media, that opens the browser, that sends a request to the server. If you're in lax mode, an external request to the page will still send the cookie. In strict mode, a request outside of the page will not send the cookie. So I tend to want to do I tend to want to do strict when I can, lax only when I have to. And the good thing about the standard is every major browser, except for the filth that's IE11 is filth. Stop supporting it, everybody. It does not support modern web standards. It's a horrible problem. They do support some of this standard, but anyways, I'm gonna stop my IE11 rant. That's what I do on the occasion I drink. I drink a little bit once in a while, and I rant about how badly IE11 and Safari support modern standards. It's a personal problem, but it's a well-supported standard here, right? This is a good job. And so the interesting note is the same site lax is now default since about Chrome 80. So they enabled it and disabled it, but it's now in there where if you set a cookie and don't declare the same site value, it's going to automatically make your cookie same site lax, giving automatic CSRF protection across the web, even when people don't implement it. This is really impressive. And this is Mike West from Google, who's the head of the W3C security working group. He's amazing that they pulled this off. And so we see up and down, this is the history. Same site enforcement is now resumed by automatically for good, just a few years ago. And so there's some limits here, everyone. Limits of the same site cookie defense. If your session management is not cookie-based, like if it's like HTTP digest or network-based session management, please don't do that. But if these types, even though they don't have cookies, they can still be request forgery based. I know I mentioned earlier that you got to have cookies for this to be a problem, but just to be a bit more complete, any automatic session management can be attacked. And the ones I can think of is HTTP digest or network-based security for authentication, which I never use, but some legacy systems do. They're vulnerable to CSRF. Also, it's my belief you should not be giving up your subdomains, right? If you let an adversary control your subdomain, like some of the software services will have like, manico.salesforce.com, you've given your subdomain away. In that case, as a subdomain owner, I can set a cookie that overrides CSRF cookies at the top level domain. That's a problem for some software as a services. That's a problem for some software as a service services. Thank you. Not all browsers support same site. That's less of a problem every day. Another defense is I can check the origin header. I do this in addition to other defenses. I don't do it as much. I don't see it as much, but I can make sure the origin matches. If the origin header is not being sent, I can check the refer header. And if both are missing, we can just fail gracefully. This is an option for legacy. And so the reason why I think this is, and again, we want the refer header often for analysis, and I can now control the refer header through a refer policy. By default, it's no longer sending the full URL. So I would override refer policy, strict origin when cross origin, so that way cross origin requests won't send the full URL, just the origin, which I can verify as part of request forwarding defense as an option, a little more of a legacy option, but still an option. By the way, you got to get cross-site scripting correct. Content security policy and trusted types is critical here, because if I got cross-site scripting in your site, I can defeat any request forgery defense like this. Twitter got hit where this URL was vulnerable to cross-site scripting. It allowed this raw script to run on Twitter's homepage. The attack then was all of this here. The actual value of that script was everything you see here. It grabbed Twitter's main HTML, ripped out the CSRF token, said something offensive about goats, tweeted your inappropriate affection with goats, and retweeted the same attack to spread it. Within 3 or 4 days, millions of Twitter users back in this era were tweeting about a love of goats whose name we should not speak. Bad attack. That's what I'm saying. All right, moving on. So what else do we got here? Here's the cross-site request forgery cheat sheet. I helped rewrite this recently. So use your built-in CSRF protection, use synchronizer token for stateful, double submit cookies for stateless, consider same site cookies and their automatic behavior as default as lax, so be ready for it. Consider implementing re-authentication, consider custom headers if you wish to, and you can check the origin and refer if you wish to as well. And please, one XSS and CSRF is all defeated, so please be sure to have great XSS prevention strategies for your app. And last, don't use gets for state-changing operation, and you shouldn't need to defend against them. Yeah, that's cross-site request forgery in a nutshell. Please give this cheat sheet a read and provide me with any comments. We're always looking to make stuff better here at the OWASP Foundation. Let's talk about server-side request forgery next. Server-side. Now, the big event, I remember this vividly. I was having a glass of milk, really ice cold, and oatmeal raisin cookies, the platonic form of cookies. The best cookie that Plato himself would say is, the highest platonic form, the ideal form of cookies is oatmeal raisin. I'm sorry, it's just true. So I'm having an oatmeal raisin cookie and a glass of milk, and CNN News in the US said, coming up next, server-side request forgery at Capital One. And milk went out my nose. I thought someone hacked my TV. There's no way CNN's talking about server-side request forgery. But August of 2019, that's exactly what happened, because Capital One had 100 million applications stolen from their AWS setup through server-side request forgery. What the heck is this? Now, I read a lot of articles about this, and I'm really impressed with AppSecCo.com. They're the ones that really got this right. Many other articles kind of flirted with the technical details. They got it right. High five, AppSecCo.com. So what is this? This is the vulnerability. Here we have CapitalOne.com, and they had a parameter that the server acted upon. Let me say this again. Capital One had a parameter in the URL that itself was a complete URL that the server would act upon. And that URL used to be like a news article. Whoever the attacker was, she knew that this was an AWS application. She was an ex-AWS employee, is my understanding. And she saw that Capital One was doing this and she couldn't help herself. She modified it. She modified it where it was a standard AWS artifact. 169.54, if you're an AWS developer, that's a standard intranet for your AWS setup. And this URL, this server is in AWS. So they're making an intranet hit to grab security credentials out of the WAF. Ever see the movie The Matrix? What did Morpheus say? Morpheus says, life, it seems, is not without a sense of irony. I'm probably misquoting him, but bear with me. But this is so ironic. The attacker, I'm a little bit of a web application firewall naysayer. It's for marketing. Don't worry about it. But the reason, this is great because here we have an attack that punches through a web application firewall to steal the credential file of the WAF, which was extracted through the WAF, allowed the attacker to log into the AWS for Capital One, navigate to the S3 bucket. You know those S3 buckets, 100 million applications, the biggest banking private data heist, one of the biggest banking heists in history. Equifax is a little bit bigger. There you go. Server-side request forgery. And again, why is this a problem? Because that parameter is acted on by a user. It used to be like a news, like capitalone.com, URL equals cap1/news. It's really poorly written, called a server-side include. And it's the URL that the server acts on as a parameter. You could have fixed this with validation. If the URL starts with https capitalone.com/, it would have stopped the problem in one line of code. And instead, we got like AWS keys getting stolen. Is this really a problem besides Capital One? Better believe it. We have GitLab with the major SSRF vulnerability earlier this year. We see Microsoft Exchange leading to 30,000 organizations getting compromised because of SSRF through Microsoft Exchange. That's pretty horrific. Let's look at it from another angle. This is something I often do where I'm sending data into the public REST service and then add with the parameter that I add to a URL that I use to retrieve intranet services. So this is hard-coded in my code, internal data, and I'm adding a parameter to it. It came from the user. Hey, what kind of parameter can I use here to mess with that path? // path traversal. So my attack would be this. Here's the URL. That parameter data goes right there. There's my path traversal SSRF attack. So internal /data // the final URL is internal admin global report. So what's the point here? I've gotten the server to change where it's loading a resource from. Hey, does that backend internal server do good access control? Mostly it doesn't from what I've seen. And it should. All of your backend services should require an active session or jot and do good access control. We always thought that access control was most important at the public endpoint. That's not true. The most important place to do access control is in the backend services. And we have to rewrite a generation of services to accomplish that goal, and it's a big problem. So how do you fix this problem? You URL encode and be specific about URL encoding. If I'm adding data to the end of a path of a URL, then I encode for the path, URL path encoding. If I'm adding data to a parameter, I do URL parameter. So what do we got? What's this? The problem is now you URL encode parameters you add to a URL. So you have a well-formed URL immune to path traversal that the server then acts upon. You know, I learned about SSRF mostly from Orange Desai. His talks here are world-class, explaining all different types of SSRF. And when I'm teaching developers to write secure code, I give them this summary. You want great authentication and great access control on your back-end APIs. The pattern where we like do security at the front end and have all these open back-end APIs, we got to stop doing that. It's nonsense from a security point of view. And if you're using a URL as a parameter, do strong URL validation. And overall, stop taking URLs as a full parameter that the server then acts upon. That's one of the anti-patterns. Also, if you're building a URL that's partially user data and partially static content, and the server's going to act on that to do intranet hits, please make sure you're building URL safely when it includes a portion of untrusted data, mostly with URL encoding to build a legal URL. And also, I kind of got this from Netflix's work. Netflix, I give them a hard time, but they also put a lot of great security resources out there. Netflix security, one of the best in the world in terms of what they've given to the world to demonstrate, to share what they've learned in their own security work. And so this is like Leaf. And hey, Leaf, he taught me like put network controls around individual services. It's really easy to set up. And now if you know that this service may only receive from that and send to that, simple network controls will help limit SSRF damage. That's worth considering. And guess what? That's my take on request forgery on the web, how to educate developers about this. I hope it helped you in some way write more secure code or do your job as an analyst. If you have any, I'd love to take any questions from you. And I'm done for now. Thanks, everyone.
Hi, Tim. So, wow. Give me a second to recuperate from your talk.
No problem. No problem.
Always overwhelming how much information you share. So, actually, I got one major question. It's actually the synchronizer token pattern. I put them also in the chat, just me. Is the same thing as the built-in CSRF token technique in modern web apps frameworks?
So you're asking me, is the synchronizer token the same thing that we see in frameworks? Synchronizer token, we're looking at this right here, right? Yeah, this is what's built into most standard web frameworks. But please confirm it. You don't just get it automatically. You often have to enable it or turn it on or specify it for certain features. It's usually available in your framework, but make sure you're enabling and configuring it properly. In almost every framework, there's a guide that shows you how to do it. It's pretty straightforward. So yes, it's there. It's not always default. Be sure to enable it and verify it carefully. There you go.
Okay. Yeah, we have plenty of time left because we should go to the whole full hour. So the next question is, do you really believe these attacks, and I put it also in the chat for you, do you really believe that these attacks can be automatically tested with DAS tools like SAP, WebInspect, etc.? I felt true detection happens only using the tools manually, like Burp. Do you agree to this?
Not at all. No, that's nonsense. Because the reality is there's an older project at OWASP called the CSRF tester. It's not maintained anymore, but testing for CSRF is trivial. You go, you make a transaction request that does something sensitive, record that transaction, log out, log back in, and replay that transaction. If it works, you got CSRF. If it doesn't, maybe you don't. So to test if CSRF is valid is pretty simple in DAS technologies. You don't need manual reviewers to find it. DAS does a good job, especially DAS where I can control authentication. Again, I log in, submit a transaction, record it, log out, log back in, resubmit the transaction. If it works, boom, you got CSRF, done. So I can do this via DAS automation pretty easily. Burp does it. I know different services do it. So I respectfully don't agree that I got to do it manually. I don't agree. Automation's critical in the era of DevOps testing, and definitely we can test for CSRF statically, dynamically, absolutely. Other questions? And by the way, if you have a follow-up comment and disagree with me, I encourage this discussion. This is helpful, so you're welcome to give me a follow-up if you wish to. Go ahead.
There's another question about Sorry, there was a poll coming up in the interface between. So the other one question would be, would HMAC signing be a valid mechanism to validate data on the URL, assuming URL data does not show off your network?
No, I don't like to, because this is a client-side control. Now, maybe you may HMAC your token, but there's no need. You can just use a cryptographically random token. So I don't want the client to HMAC stuff. So I don't see HMACs as part of CSRF defense as viable. In fact, I surgically removed that from the cheat sheet after getting other experts to vet that that's not a really solid defense. There's no need to use HMACs and CSRF protection for my own work. That's my opinion on that. And I'm open to change my mind if you give me a good example of how to do it. But all the previous cheat sheet talks on HMAC, when vetted by other experts, this is not a sensible defense from what I know. But I'm open to changing my mind if you give me better evidence.
I think I really like that because, as you say, I think there are not much people who know the same as you as much as you, but still, you say sometimes you change your mind and you have to learn from what has changed in the things. So we have some cheat sheet, we recommended it, and then we have to change it because we find out it's not true. I think that's a very valid that nobody has all the knowledge, but we learn continuously.
Yeah, I'm a teacher, but I'm really a student. I'm constantly learning new things on a daily basis, and I'm a scientist. I'm happy to change my mind if you give me good evidence. But the evidence I've seen on doing signing and HMAC for CSRF defense, it's a huge complexity in key management for no real benefit. There's other ways to solve CSRF in a much more straightforward manner. That's what I recommend.
Yeah. Here goes another one. So my server-side code has a web client that accesses a third-party URL based on the user's input. The danger, according to you, is the user can provide an internal API and access sensitive info, right?
Absolutely. Let me go back to that slide again. So the issue here is, again, you're taking data from a user that you add to another fragment of a third-party URL. And one of two things is going to happen. Either I'm able to subvert the entire URL and change what resource the server loads, or more in my code, I see this stuff where I'm able to subvert a portion of the URL, and using path traversal, I can still reroute that URL in various ways. Again, I'm trying to send data to the server to trick the server into loading content that it didn't intend to load for that request. That's what server-side request forgery is. I send data to the server, and now the server is going to visit that internal link in a path different than what they expected by doing / and something else. There you go. There's your answer.
Thank you. So another one. It's automated scanners improving on their false positive ratios for cross-site request forgery.
I mean, a lot of us focus on scanners. I don't think security testing is that big of a deal in my world. It's not. There's so many scanners. They're getting good. They're decent. We augment scanning by using a variety of scanning. The biggest anti-pattern, I think, is when you go buy a really expensive scanner from one vendor and that's your whole program. That's foolishness. You want to use a combination of DAST, SAST, and I usually use two SAST products. I usually use SemGrep for my immediate check-in defense, and then something like check marks for my daily long scan. So I love SAST, and I use multiple tools usually. For DAST, I love Zap, I love Burp. There's many others out there that are really solid. And for SCA, there's OWASP dependency check. There's vendors like Sneak and others who do a great job in that area. So I want to use a combination of those three tools. And I think IAST is kind of expensive, but it gives me some great results in dev testing. Some of my customers use some of these famous IAST tools. They're expensive, but they find some good stuff. So don't depend on any one tool. Have a combination of tools, mostly that are automated through DevOps lifecycle. Then you run your other longer scan tools in the evening as a more long form scan. And that's how I like to do assurance. And I can do this turnkey these days. I can do it in GitHub in 5 minutes. I can ramp up, different servers and get this running a lot more easy today. So in my world, getting up a rigorous testing program, it's easy. They find CSRF, no problem. False positives, of course, you review. It's part of triage, is part of application security, and try to tune your tools to do less triage. And in most teams, we got mature capacity in this area these days. So what's the hard part? Getting developers to write secure code. This is my job in my world, but I care more about how do I get developers to do this right? And testing is no big deal. We have very mature testing now to find these problems. You got to go fix the bugs. That's the real issue today, in my opinion. Done.
Yeah,
What else you got?
I think using one tool for security validation is like using the OWASP top 10 for a security program, right?
I'm gonna steal that quote from you, Martin. Using one tool for your AppSec program is like basing your whole AppSec program off a top 10 list. I agree. High five.
Okay.
Look, I even said something nice about I asked. I almost never do that, but I did. So I'm not trying to use a collection of tools, including I asked. You can quote me on that, my I asked friends.
Okay. So we have still plenty of time left, but I see the questions getting slow. So there's one question more on a personal note. What's your favorite flavor on stroopwafel?
Oh, maple stroopwafel. Someone brought me maple stroopwafel when I was in Netherlands, when I was in Amsterdam last giving a talk, and they were like, "Sir, this is going to be the best stroopwafel you've ever had, made fresh from my town." And I'm like, everyone's handing me stroopwafels. I had too much sugar, stacks of like dozens of them. And I tried a little bit of all the stroopwafels given to me in Amsterdam. And that guy who claimed his maple homemade stroopwafel from his town was the best, his was not just the best, it was in a whole different category of excellence. I will always remember the moment that I bit into that maple stroopwafel, and it was the best ever. I won't forget it.
Yeah, it's very funny to see gourmet stroopwafels coming up. I haven't been out there for the last 2 years, so I don't know if they still exist, but it's very interesting.
And Martin, I'm back on a no sugar kick. I'm just doing ketosis. I eat meat and vegetables so I can keep my weight down. And it's very effective. I don't do sugar anymore. Boo. Boo sugar.
Yeah. And also a nice comment, I think we know both. It's Kevin Wall says he feels cheated because you didn't cover click checking.
All right, let's do it. Let's do it real quick. Kevin, he's right. Hang on for a second. We got time. So Kevin, you are right. Even though I really enjoy cheating you in general, I will talk about clickjacking right now. Let's do it. Let me see if I can find it. Do I even have that presentation anymore? You're right. I forgot to add it in. I said I would in the topic. Where is it? It's one of my oldest slide decks ever. Hang on, Kevin. I'm with you. Hang on. Click. See if I can find it in Pro Presentations. Kevin's right. Kevin's always right. He's especially right today. Here you go, Kevin. Clickjacking in a couple minutes. Clickjacking was originally called the UI redress attack by one of the original Mozilla developers. Is to trick a user into clicking on something they never had to click on. It's abusing framing and CSS transparency. So here's my site. And the reality is it's evil.com, and this is an overlay. Because what's going on here is there's an iframe with a certain width, height, and position with an opacity to make it invisible, and I'm framing Gmail here. Now this is it's an active iframe on the top of the Z order stack. It's up front, it's the front thing I'm gonna face as a user, but it's set to opacity 0, so it looks transparent. Excuse me, Kevin. Even though it's there, it's transparent on the top of the Z order stack. So go back. When I click start game, when I click on it, I click one player first. When I click one player, I'm really clicking select all on the above obscure iframe that has an opacity of 0. And when I hit start game, I'm really hitting the delete button. That's clickjacking. When you trick a user basically into clicking or typing into something that they don't realize what they're really typing into. So the way we traditionally solve this is with X-frame options. You can say X-frame option deny, and that will stop other sites from framing your page. So you have a page that's very sensitive and you add X-frame option deny, nobody else can load your page in an iframe. If you say same origin, then the same origin. And Kevin, the origin is the port, the host, plus the protocol. It's not a subdomain, it's host plus the protocol plus the port, Kevin. And so if you're loading a X-frame option same origin page from the same origin, you may frame them, but no one else may. We can also say X-frame options allow from, but many of the browsers don't support this, so it's not going to be effective. Now let's break out of this for a second, Kevin. So that's traditionally how you solve this, and browsers support it, the X-frame option response header, forever. Now, wait a second, Kevin. I'm not done yet, Kevin. The other thing you can do is you can say CSP frame ancestors, right? Let's go take a look at this real quick. If you're using content security policy, you can now do allow from and have a list of valid origins where the other X-frame option didn't support that. So I can say content security policy, frame ancestors, and have a list of parents who are allowed to frame me. And so there we go. Like frame ancestor self, that's my origin, can frame my own page. And this other site can frame my pages. It's really simple to deploy this, Kevin. CSP frame ancestors, if you're a CSP shop, or X-frame options, probably same origin if you want to support older browsers as well. Kevin, there's your answer, sir. I hope you feel less cheated in this talk. And that is the third kind of request forgery solved in a pretty straightforward way. Boom.